This is section 1, Introduction to Descriptive Statistics. Descriptive statistics are a way to measure. Another word for describing is in statistics is to measure something. So if we want to make a description of, say, a variance of the length of pipe, we could measure that. And what would we want to measure it for? Well, that has to do with inferential statistics. Inferential statistics means that we want to infer something or do something about it. So descriptive statistics is a summary of a set of numbers without interpretation. Inferential statistics is drawing conclusion from these set of numbers. In the first 3 sections of this course, we'll be discussing descriptive statistics. In the next 3, we'll be discussing inferential statistics, otherwise known as hypothesis testing. And then in the final section, we'll be looking at correlation and regression. Inferences can be made about samples of a population with some limiting assumptions. So, for example, let's say we have a population that we want to know something about. Let's say that we want to know the average age. It might be very difficult to measure everyone's age in that population. And so we draw a sample from that population and we make sure that this sample is random. It must be representative of the population that we're drawing it from. And then we measure something. So in this case, we would want to measure the average age of the sample. So let's say that the average age of the sample is 35. We denote the average of a sample by an X bar. So the sample average is 35. But we know that the sample is not going to be the same as the population, but we'd assume that it's something close. And so we make an inference about the population. We would say, since the sample mean is 35, we would assume the population mean, and the population mean is given by the Greek symbol mu. We'll be discussing symbols and the way we describe data in a little bit more detail. So all of this leads to decision making. That's the purpose of statistics, is we gather information, we collect samples, we measure things about those samples, and we make inferences about the population to make a decision. It's most critical that we understand the end before we begin. So we want to know, or at least have some idea about what we want to do. So we always state the decision to be made. We start with that idea. Now in this class, you're going to be given the data. So these first 2 steps are going to be given to you. We'll primarily focus on statistical analysis and then especially on interpretation. And then you'll be asked, okay, what do you do? So this is where this class might differ just a little bit from, say, a math statistics course. In a math statistics course, or maybe a marketing statistics course, they would spend a lot of their time on the managerial problem, the data collection, and the statistical analysis. We're going to focus on these last 2. We're going to use the computer to give you the statistical analysis output, and then it's going to be up to you to understand or interpret what that output is telling you. So I go into quite a bit of detail here in the managerial problem, the data collection process, and so on and so forth. But I want to just bring out a few very important points, and these are highlighted in yellow. And the first point is that in real life, finding the managerial problem is crucial to finding the best managerial solution. Oftentimes we go about collecting data and doing a lot of work before we really understand what is the problem, what is the thing that we're trying to find. We should anticipate the solution. We should have an idea of what the result is going to be even before we start the data collection process. And that is important here in the managerial solution. You'll be expected to know what to do with the analysis. So you should almost anticipate this will be the answer. How do I get to that answer, or how do I support that answer? That's the analysis that we'll be doing in this course. So let's move into the different types of data that you'll be dealing with. And there's this taxonomy of data. And it starts with the most unuseful, I guess you would say statistically it's unuseful. It might be very useful in certain contexts. And that's nominal or categorical data. Categorical data are place fillers. They're basically buckets. So for example, it might be the type of occupation or the political party affiliation, school major. Great example for a categorical variable is that question they always ask on surveys. What is your race? Race is a categorical variable because you wouldn't say one race is better than the other unless you're a racist. But there's really no order to those. They're just place fillers. Now we can use categorical variables and we can create dichotomous variables. Dichotomous variables will commonly be more useful. These are categorical variables that have only two possible outcomes. So for example, male and female. It really doesn't matter whether you give the males a 1 and the females a 0 in your data set, or you flip that. The fact is that there can only be one or the other is important. Next, we move into ordinal data. Now, this is categorical variable that may have some type of order. Rankings are typical for ordinal data. So when we rank a system, we wouldn't know how much further the second is behind the first, but we know that the second is below the first. These are what are called qualitative measures of data. Qualitative measures of data are very limited in our statistical use. Quantitative measurements are what we typically want to use. Now, dichotomous is commonly considered a quantitative type data source. So there's two types of quantitative data. The first is interval and the second is ratio. How they differ is not so important as you understand the difference between a quantitative measure and a qualitative measure. So in a quantitative measure, there is not only order, but there is also interval. So now we can say if you are 15 and your brother is 13, not only are you older than your brother, but you know how much older you are than your brother. And that is an idea of an interval measure. Now, an interval measure, a pure interval measure, has no absolute 0 point, or you would say the absence of something really doesn't mean anything. So the scale is somewhat arbitrary. Test scores are commonly on this type of scale. If I took the GMAT or graduate admissions test for business school, I wouldn't ever say I got a 0. 0 really has no reference. You'd get somewhere between 350 and 800, and you could say that a person that scored a 400 and a person that scored an 800, the person that scored an 800 was twice as high as the 400, but it really has no absolute point. That's where ratio data is more informative. In ratio, it is a quantitative measure that has an absolute 0 point, or the absence of something. So an example might be the return on your investment, the number of votes you got, the salary, or age. Age is a ratio, it's a quantitative figure, and 0 really does mean something.